Okay everyone, so this is our first lesson on algebra, and today we are going to be learning about variables. So the first thing is that in algebra, what is a variable? Before I go to the next slide, you might want to be thinking about the word variable. What does it mean? If something is variable, what does that mean? You might want to pause the video and have a think about that. Now, you might be thinking that if something is variable, then it's changeable. You know, if we say that the weather is variable, then that means the weather is changeable. It changes. So that is closely linked to what we're going to learn about. So here, I don't know if any of you have seen the film Babe, but this is a little picture from that film where the farmer here is holding Babe the pig, and I don't know if you've seen the film, but there's part of the film where they need to know how much Babe weighs, I'm sure, and we don't know how much Babe the pig weighs. Maybe pause the video now and take a guess at how much you think Babe the pig weighs. Let's say we're going to take a guess in kilograms. Okay, so you should have taken a guess. I mean, my guess is going to be he's quite small. I would say maybe like 35 kilograms. That's my guess at how much Babe the pig weighs, but your guess might be close to mine or it might be far away from mine. But the point I'm trying to make here is we don't actually know the mass of Babe the pig unless we take him and put him on some scales. So that unknown is what we call a variable. The Babe the pig's mass is an unknown. We do not know it. And in algebra, that's called a variable. And there's lots of unknowns. For example, we could say the cost of a Mars bar is an unknown, unless we go to the shop and double check. But anything in algebra, any number or value that is unknown is called a variable. And you might have come across that in science as well when you look at dependent and independent variables. They are numbers that can change and we don't know them. So we have seen in maths that we've done before, we have seen unknowns and variables. So this question here is the perimeter is 16 of the triangle, find A. Well, A is an unknown here. We don't know it yet. We know how to find it, but at the moment it's an unknown. And you can see that I've put the letter A there to represent that unknown. In this question, we have a bar model diagram where we can see that the length of those 5 bars is 35, and we want to find x, which is one of the bars. Now, x in this question at the moment is an unknown. We do not know it. So we represent that with a letter in algebra. And this last question is an angles question. And once again, we can find the value of this angle y. We know the maths to do that, but at the moment it's an unknown. So we've represented that and put a letter there instead. So in algebra, if a value is unknown, it's called a variable, and we represent that with letters. So a key concept, and this is something that you should write down. The key concept here is that a variable in algebra is an unknown. It's a number that is not known. and we represent that with letters. And I've just given you some letters of the alphabet here. I could have put all the letters. But a variable is a value that we don't know, and we use letters to represent them. So that's the first thing. So here I have a bar model diagram, and each bar is worth 7. Okay. Now, if I wanted to find the full length of this bar, I could do a couple of different things. I could do 7 plus 7 plus 7 plus 7 plus 7. That would give me the full length of the bar. Or I could just do 5 multiplied by 7. That would also give me the full length. Or I could do 7 multiplied by 5. That would also give me the full length of the bar. So there are 3 different calculations for me to get that unknown, the full length of the bar, the whole thing. So if I do an algebraic example here, instead of each bar being worth 7, it's going to be worth A. That could be 7. A could be 7, and we could have 2 of the exact same question. But A could also be another number. It could be 2. It could be 25. It could be -3. But because we don't know it, we're just going to call it A. Now, to get the full length of the bar, I could do the same 3 calculations. I could just do A plus A plus A plus A plus A. That would give me the full length of this bar. Or I could do 5 multiplied by A. That would give me the full length of the bar as well. Or I could do A multiplied by 5. That would be the full length of the bar there. So here's another bar model, and I want you to copy this down, the bar model, into your book, and I want you to answer this question. If each block represents G, what are 3 ways to calculate the total? So pause the video and do that now. So you should have the addition sum, G plus G plus G plus G plus G plus G plus G, because we have 7 G's. Or we can have 7 multiplied by G, or we can have G multiplied by 7. Those are the 3 calculations to find the total length of the block. Here's another one for you to have a go at. Pause the video and do it now. Okay, so for this one, you should have your addition sum, and then your 2 multiplications or your 2 products. Okay, so just to recap some key concepts that we've just gone over. We can multiply a variable by a number. Okay, and in algebra, we actually just take out that multiplication sign and write any multiplication with variables as without the multiplication symbol. So 5 multiplied by A is equal to 5A. The reason why we do this is because algebra is about being quick and simple. And taking out that multiplication symbol makes this shorter to write, and it looks more simple than this. Now, before we go on, we would always have to make sure the number goes first, okay? So for this one down here, we would write 2A and not A2, and this is a really common thing to do, okay? So if I was trying to write 2 times A, I would write 2A, not A2. Okay, in this one, I wrote 5 times A, not 5A. I wrote 5A, not A5. So just at the top of this slide here, we've got a numerical example. 7 times 7 times 7 times 7 times 7 is equivalent to 5 times 7. And A plus A plus A plus A plus A is equal to 5 times a, which is 5a, the short and simplified version. So here are 6 questions. I want you to pause the video and please write the equivalent calculation to these 6 questions in your book and use these examples here to help you. So pause the video now. Okay, so I'm going to put the answers up now and talk through these questions. So this first one, we've got 5 plus 5 plus 5 plus 5 is 4 multiplied by 5. I could also have 5 multiplied by 4, but I don't have the space here. For this one, p plus p plus p, well, that's equal to 3 times p and p times 3 as well, which is equal to 3p. That's our shortened version. In fact, this one here, I've actually not done this one quite correctly, have I? 3j is equivalent to 3 times j, which is equal to, and I should have my addition sum here, j plus j plus j. Over here we have s plus s plus s plus s plus s, which is equal to 5 multiplied by s, and s multiplied by 5. And that is equal to 5s. And then h plus h plus h plus h is equal to 4 multiplied by h. Also, h multiplied by 4 is fine, but when we write it in the simplified and shortest version, it's 4h. And the last one, y plus y, we should have 2 multiplied by y here, which is equal to 2y. So I want you to pause the video and have a go at these 9 questions in your book. Notice that the first one is actually an example, so you don't need to do that one. You can just copy that one out, and you're going to do this in your book. There is an extension question at the bottom here if you finish early.